Evening, sir. Am I hear me? Mic check. Hello.
Good evening.
Evening.
Good afternoon, students. Just letting you know that I'm here, giving you guys enough time to sort yourself out a little bitish. So I'm here. Get ready because we are about to do some revision. Maybe I could do that. Maybe I could read a revision question in the meantime while I wait. All right. How far reach, Ryan? Leave office yet?
Trick you to the boss. I reach home already.
All right. Same way, so. All right then. Just a few more minutes.
All right, sir. No problem.
Easy. All right, guys. I'm here. I'm giving you an opportunity to complete. Okay. All right. So I I have seen your message, and you need to link me. You know who you are, so just link me, and we can set up something. Um, yes, Lexton, good day to you too, sir. All right, guys. Here's a question that is posted. I am going to give you a few more minutes. By the way, has anybody completed this question yet? Yeah? No?
Mm.
Sorry, somebody speaking? Not hearing you.
No, sir.
Oh, okay, okay. Sorry, just hearing you now. My system was low. All right, thanks much. Continue working. Let me know. Just don't just finish it and sit there because I'm muting and I'm here um trying to prepare something else for you for tonight. So just shout at me, please, when you finish. Thanks. Hello, hello, hello. Anybody finished? Somebody?
No, sir.
All right. Hurry up. Hurry up. Get ready to go.
Sorry, I just sent you an image. Can you look at it for me?
Where, WhatsApp?
No, man. Zoom.
All right, so, all right, no. So I'm using two devices, so let me go and look at the other one. Okay. Hold on. All right, so I'm seeing it, Christy. Without telling you if you're right or wrong, one of the things I'll say to you and to the class, whenever you're writing your final answer in Maclaren's, always put it in its lowest term. If it can be simplified, go ahead and simplify it.
Oh, okay.
Come on. Always try to do that every single time. You lose marks for not doing that, actually. But I like what I'm seeing. I'm not interested at this stage if it is right or wrong. I'm just interested in you be able to understand what is happening. Very nice.
Yeah. All right. Thanks, sir.
No problem, Papa. All right, I'm going to. It is 5:46. I have technically about an hour left, and we need to go. We need to go. We need to go. If it is equal, it's going to be equal to 0. Horizontal. Right, I'm talking about vertical. So what the horizontal is. So the horizontal is going to be the vertical is going to go to the denominator. All right. Trying to find the questions I can. All right. I'm trying. Anybody else finish the question? Hello.
Hi, sir. Just settle down.
Welcome, hon. I saw your message. What about the rest of you? Anybody else? Those of you who are here, there are like about 10 of you here. I saw yours, Christy. Anybody else completed something or made an attempt?
Sir,
Sir, I made an attempt, but I feel like I do rubbish at the end.
You made an attempt, but you feel like you did rubbish at the end. All right. Why you feel like that? What happened?
Because one of the last examples that I remember you giving us, the answer was close to the starting. Right.
Oh, don't look at it. Don't look at it like that. The answers. Okay. So everything is dependent upon the given function. So you may get a function that when you work with something, it looks far off. So there's no sequencing how the stuff will look. I don't want to do the question and thinking that it's going to be, close to something like we did before. It could be far off because you could get something that is exponential. You could get something that is logarithmic. You could get something that is a polynomial, as I've shown before, and you could get something as a rational function. So I can give it any of what the syllabus says for unit 1. Logarithmic function, exponential function, and any of the other forms of the differentiation, quotient, product, chain, any of those. But let me hear from you though. What you got for the first differential?
All right, so the first differential, I got -2 over x plus 1 to the third power.
And when you substitute 0, what you got for that?
-2.
When you substitute 0 into the original function, what you got?
1.
What's the second differential? By the way, anybody agrees with Yanni for the first differential?
Yes, sir.
Yes, sir. Yes, sir.
Okay, what you all got for the second differential?
6
Negative.
over
6, sir.
6.
6 over x plus 1 to the fourth power.
And f double dash of 0 is?
6.
6.
And what is f triple dash of 0? I mean, f triple dash.
Negative.
4 over x plus 1 to the fifth power.
F triple dash of 0 is?
-24.
What is f to the fourth dash?
120.
120 over x plus 1 to the sixth power.
And f to the fourth of 0 is?
120.
120. All right. Do you still have that mid-semester paper, Yanni?
Mid-semester paper? Yes, sir.
All right. Go and look at it for me, please. And I love you still.
You're saying I left off a negative sign. So I don't leave off a negative sign this time.
You didn't, but all I'm saying that you're now doubting yourself.
No,
and I don't know why
that's not where I'm doubting myself, is I don't fully understand how you move on.
This piece here, look,
okay.
This is the piece you don't understand?
Sir, no, you see the thing, what caused me to have doubt in my head, sir, is the fact that I started out with a fraction and now I am getting a chain. So that is what I was thinking, that I was doing something wrong down the bottom part when I do the substitution into the function.
All right.
So that is what.
Fair enough. But a while ago you say you're not doubting yourself, and then you say you're doubting yourself. And based on what it is that I heard you say, I could tell you that you're doubting yourself. And at this stage, Annie, I know you know how to differentiate. So if it look like it's not something we're looking at and you double check your differentiation, to hell with it. You know you're on the right track. So very good. Rashim, I heard you coming in, Papa, and I'm proud of you. And I heard some others coming in too. Very nice. Extremely powerful stuff in terms of the differentiation. I'm not even interested at this point in time to write the Maclaurin's expansion. I just want to make sure that we can go in and do the differential and find the f of 0, zeros to the differentials. And then we spend some time today on going and substituting our answer and stuff. So we're going to take it in stages. So if you were to ask me, I'm very excited for, okay, Papa, just be safe. Just try and follow suit what is happening. I'm pretty excited for what is to come. If you don't know how to substitute into the original function, into the Maclaurin series just yet, that is fine. And as I told you before, and hold on a minute, please. As I told you before, don't know if it's a good thing or a bad thing that I did calculus 1 with you all, but I know the level of differentiation that you guys come to the classroom with. I know last year, this time, I had a group of calculus 2 students. I didn't teach them calculus 1. And this time in the semester, I wasn't anywhere where we are because I had to be going back through differentiation. What am I saying? And they were good students. They did pretty well, but the differentiation was weak. What am I saying? Comparing them to you. And if you ever tell them that, because they're my year 4s now, if you ever tell them that, but you are in a better light than they are now, because we started off pretty slowly because I had to get them up to the point of being able to differentiate. You have a drum start. So it's like running a 100-meter race. And you have a 20 meters drum. You say him can't catch me. All if me can't run, him can't catch me. Him can't catch me. All right? So again, I'm going to congratulate you. Those of you who know you're struggling and especially not remembering how to differentiate, you know what you need to do. All right, let's go. Let's go. All right. So it says, let f of x equals 1 over x plus 1 over squares. Determine the Maclaurin's expansion of f of x up to and including the term in x to the 4th. All right. All right. Let's go. We know that this is a Maclaurin's expansion. We know it. But in order to do this, we have to first evaluate f of 0. Let me get my spotlight here. So those of you who are not really following this stuff, this is your teacher again going through with the time that is left to go through the stuff with you. In Maclaurin's here, this is my f of x. This f of x is the same f of x as this one here. It looks alike. The only difference is one is pink and one is black. But if I want, I can put both of them to the same color. It's the same thing. Now, what I'm trying to do is to move this f of x from this form, 1 over x plus 1 to the negative, to the positive 2, into this expanded form. Into this expanded form. All right? Now, look at what we're talking about now. I need to find f of 0. Oh, f of 0, sir, is you getting f of x, and anywhere you see x, you put 0. So, sir, I can evaluate f of 0. But, sir, you want me now to evaluate f dash of 0 of x? Oh, but f dash, sir, there are 3 things here now. F dash is the first differential of f of x. Got you. Then when I find the first differential, anywhere in the first differential I see x, I put 0. See it here? That will give me f dash of 0. And then now I'm going to multiply that by x. So this gives me my second term. Watch this one here now. This one is the same thing. I'm finding the second differential of the function, substituting 0, I'm finding it at the point x equals 0. Then I'm dividing that answer by 2 factorial, and then I'm multiplying it by x squared. So forth and so on. It says up to and including the term x to the 4th. It means I'm going to do it 4 times. 5 times. All right? So it's not the 4th term. It's actually 5 terms that I'm going to be getting, because this f to the 0 is going to be the 1st term. And f dash of 0 is going to be the 2nd term, right? So I'm going to have it up there 5 times. So the first thing that I'm going to do, I don't like typing this thing here. I don't have enough space. All right, so over here, so I put my side work, and over here, so I put the good work. So the good work now is a function f of x, which is equal to 1 over x plus 1 all squares, which is this. And I'm finding it at the point x equals 0. I'm finding it at the point x equals 0. Now at the point x equals 0, what I'm going to have is, at the point x equals 0, anywhere in the function I see x, I put 0. So this is going to be 0 plus 1, which is 1, and 1 squares is 1. 1 over 1 is this 1. All agreed?
Yes, sir.
All right. Now, if you're not following me, I want you to stop me, because after this, I am going to look at two little something. Yeah, two little something. And then I'm going to close out unit 1, jump into unit 2, chuck off in a unit 2. All right? Then I'm going to find the first differential. Now I heard Yannick say, sir, we book up in a chain, I'm a gamma quotient. If I want, I could convert this to a chain rule, but I just decided not to. And I went ahead and just used the quotient rule. Watch me. The denominator, see it here, so, times the differentiation of the numerator. The differential of the numerator, 1 constant is 0, see it right here, so. Minus the numerator, minus 1, see it right here, so. Times the differentiation of the denominator. I'm differentiating the denominator as a power. So it's going to be 2 in front of here, x plus 1 to the first times 1. See here, 2, x plus 1 to the first. Sorry, never write the first, neither here nor there, times 1. Done. All over the denominator squares. The denominator squares is going to be x plus 1 square. So when I fix up this now, all of this goes to 0. So I'm going to have negative 1 times 2 is negative 2 times 1 is negative 2. But this x plus 1 can cancel off into one of the 4 of these x plus 1. So we have x plus 1 to the third, see it right here, so? And then we have negative 1 times 2 is negative 2 times 1 is negative 2. So this is my first differential. That's my first differential. All right, as I said before, there is a little line, an extra line that is missing. I don't like typing this part of the stuff because it's online and I am doing the work. Like when I gave you this work a while ago, I was actually preparing and getting some questions for you for the other stuff because I am behind in, not behind in knowing what I want to present, but in giving you some extra questions. I was writing some questions for you. Didn't have the time to type those, but neither here nor there. We have enough devices to use to write and so forth and so on. All right?
Sir,
Yes, Papa.
the time when you did talk about the stylus, did he get it? In
Yeah, man,
regards to write.
Yeah, man, I have it, man. Yeah, man, yeah, man. I have my writing device.
Oh,
Yeah, man.
okay.
Yeah, man.
All right, good.
I have it, Papa. Thanks much. All right. So this is my first differential. My first differential. Now remember, when I get my first differential, I must find it at the point f dash of 0. I have to again find it at the point f dash of 0. Anywhere in the function f of x, f dash of x, I see x, I'm going to put 0. That's what it means. Anywhere in the function f dash of x, I see x, I put 0. Watch me. 0 plus 1 is 1. And 1 cubed is 1. Negative 2 divided by 1 is negative 2. Let's go. I'm differentiating here in order to get my f double dash of x. Remember, you can't leave the function like this. If you leave the function like this and substitute 0, you will get negative 2. But I guarantee you cannot differentiate this function like this. You must have a single numerator, or else you can find yourself in a very sticky situation. I guarantee you. So I want you to work with me. Let's go. The denominator, bam, see it here, so? That's the denominator. Times the differentiation of the numerator, which is a constant, 0. Minus the numerator, oh, so I have minus. Oh, the minus sign is fixed in the quotient rule, but the numerator is a negative 2. See it here, so? So it's minus a negative 2 times the differentiation of the denominator. Now watch me. The denominator is a power again. I know my good little friend last semester struggled with the power rule, but I know she has gotten over it. It's going to be 3 times x plus 1 to the second power times 1. See it here? 3 times x plus 1 to the second power times 1. All over the denominator squares. X plus 1 cube squares. X plus 1 cube, all squares. X plus 1 cube, all squares. So what I have is x plus 1 to the 6th power. I wrote it like this time because I want you to be able to see what is happening here. Watch me. All of this goes to 0. Negative 1 times negative 2 is positive 2. Positive 2 times 3 is 6. 6 times 1 is 6. This x plus 1 squares will grow into all of this and leave x plus 1 to the 4th. See it right here, son? Yannick, it so happened that when you do the first 2 of these questions, you can see a pattern. So you know that the denominators remain the same, will remain the same in all of the functions, the differentials, and with the exception of the powers. But when you substitute 0 in there, you can have 0 plus 1, and 1 raised to any number is still going to be 1. So if you recognize what is happening here, all of the functions, the numerator equals f dash of 0. Sir, will it always happen like that? No. No, it will not. And that's the point I was trying to make, say to Yannick earlier. It will not in all cases. When you start working the question, you will see some patterns. This is x plus 1 to how much power here, so?
Two, sir.
So you're asking the class or a person?
Say it again. Sasha, I hear saying something, Sasha, I didn't get it.
Never mind.
Okay. This is x plus 1 to the how much now?
Cube.
X plus 1 to how much?
Fourth.
So if you see that this is x plus 1 to the second power, x plus 1 to the third power, x plus 1 to the fourth, can you hazard a guess for the next one? X plus 1 to the how much?
Fifth power.
Yeah, duh. And the other one has to be x plus 1 to the 6. So will it always be like that? And I'm saying to you, you will always see a pattern, but the pattern is not going to be to the second and then to the third and then to the fourth and then to the fifth. It depends on the function. But after working the first 2 or 3, you will see a particular pattern that comes up. You will see a particular pattern that comes up. There's another pattern that comes up here with those 3 that I've done. What pattern are you seeing?
The one with the
Positive.
zero, sir.
Positive and a negative, then a positive again.
Very good.
Yeah.
A
so-
positive, then a negative, then a positive. That means that f to the third is going to be what?
Negative.
And if it is not negative, stop and
Yeah,
double
answer.
check. Stop and double check, because you will see a pattern that comes up. No, you have to be, yeah. Hello. You know that I teach. So you have to recognize that you have to recognize while you're working this, just look for a pattern, no? So that at least in your headspace you can say, okay, this is what I'm expecting. No, hear me out. If when you work it and you can't see the pattern, in Jesus' name, don't sit down and try to figure out how the pattern works. Just continue working. Identifying the pattern early will only help you to know that you're on the right track. But if you're not seeing the pattern, so what? Just continue working. Just be meticulous so that you're not making any errors with it. All right?
Sir.
Yes, please.
All right. So yes, that is how I get along with maths, right?
Mhm.
But when I see something that I am not used to in terms of the question, where
Mhm.
you wouldn't get that pattern, then that
Mhm.
is my problem.
Mhm. Don't worry about it, Sash. As I said before, I am finishing off this topic. But one of the things that I'm going to be doing, Calculus 2 is quote unquote shorter than Calculus 1, but you have some deeper concepts to learn. One of the things that I'll try and do is my little grace period that I give before the start of the class, I will drop in a question or 2 as a refresher. Meaning, so those who are in transit can go on, take out pencil and paper and do some work. Not if you're driving, Ryan, please don't. When stashing at the trunk, she can go on, even work out some mental math.
Terminate I chose today.
But this is just to give those of you an opportunity to not to forget the areas that we've once covered, right? Helping you out for the finals. All right, let's go. Differentiating this a second time, a third time. The denominator, see here, times the differentiation of the numerator, 0, see here, minus the numerator, minus 6, times the differentiation of the denominator is going to be 4 times x plus 1 to the third times 1. See here, 4 times x plus 1 to the third times 1. All over the denominator squares, and I'm just going to write x plus 1 to the 8. Why 8, sir? Because all of this is being squared. And you multiply the second power by 4 to give you 8. Remember, we did that in Calculus 1. All right, let's go. All of this goes to 0. Negative 6 times 4 is 24. Negative 24 times 1 is negative 24. This x plus 1 to the third will cancel out 3 of these and leave to the 5th power. See it right here, so? We know the denominator, we ain't go to 1, so we can have negative 24. And it did say that we need to go to x to the 4th. Now you recognize x to the 4th corresponds to f dash to the 4th power. X to the 10th power corresponds to f dash to the 10. So we have to go to 4 differential. The denominator of this times the differentiation of the numerator, which is 0, minus the numerator is a minus 24. And even if you never put in this minus sign here, you are going to end up with a positive, a negative 120. I know that the sequence don't say we have two negative numbers or two positive numbers coming together. So you just go back and can double check to see what is happening. And then the 4 cancels out of 10 of this, you're going to have 6 left. But you know, because if up here says 2, then 3, then 4, then 5, this one must be 6. Right? Is there any other pattern that you're seeing? Finally, before I go into the other part, is there any other pattern that you're seeing?
So once the numerator is a constant, you'll always have the left-hand side being 0. That's one.
Let me answer a question.
Sir.
Yes, Papa.
Oh no, wait, hold on. Well, me see a pattern, but a pattern that kind of don't make no sense.
Well, that means that a pattern then. And I'm gonna spend a few minutes, and anybody see can just shout it out. I want you to look at this f of 0, f dash of 0, double dash, triple dash, and to the 4th dash, and see if you can see a pattern right here. So does that pattern always work? No.
Yes, sir, I'm seeing a pattern.
What pattern are you seeing, Young?
All right, so when you
go ahead.
All right, so when I multiply each of the answer by the number that would come in, like say, all right, I'm figure out what I want to say. All right, so for 1, you're going, when you're creating a second equation. So if you multiply 2 by 1, you get 2. And then the next one, you're creating a third equation. When I multiply 2 by 3, I get 6. Fourth multiplication, fourth equation, 6 by 4, 24. Next one, 24 times 5 give you 120.
That was what I was looking at, sir, but I was looking at it from the power and the numerator view. But yes, the thing is that the signs would be different. What the negative would be positive and the positive would be negative. That's what I'm saying. It never make no sense.
But Rasheen, you recognize that the signs will alternate.
Yeah, from when it go over, yeah.
So what Yannick is saying, well, I think you said it, both of you came up with something. You said power, she never said power, she said the third one. But I'm gonna use what she said in the first part, and then your last part, Rasheen. 1 times 2 is 2. 2 times this 3 is 6. 6 times this 4 is 24. 24 times this 5 is 120. What if I were to go to the 5th one? Can I guesstimate what the 5th one is going to be?
It would be 6 times 120, but the answer would be a negative.
Very good. It would be negative 720. Excellent. So it would be negative 720 over what?
Over x plus 1 to the 7th power.
Voila.
Right.
Voila, 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 voila. Now, when you must glad I'm not a teacher, you know. If I got look at school, you think teacher tell you anything, you better sit down and figure it out yourself. Figure it yourself. So let me go back to what Yannick asked. Earlier. Sir, I kind of doubt to myself, but no. The truth is, when you get the question, you're not going to see the pattern immediately. It is when it is that you start, okay, scratch that. And I'm not being rude right here. I'm just gonna ask, okay. Matter of fact, I'm gonna ask I'm gonna ask Ryan. We can't fight it out after. Ryan, you come from country?
Yes, sir.
Was that a yes or no?
Yes, sir. Yes, sir.
All right, good. And don't tell me say don't think that I'm telling you that you look like country by the scholar upon you know. No, I know why I asked. What is the difference, Ryan, between okay? How do I know? How do I differentiate? Oh, help me, Lord. How do I differentiate between a banana plant and a plantain plant?
When they shoot.
Good answer. Good answer. No, let me tell you what happened. You are moving in the direction that I wanted it to move. So you can't look at the question and know what the result is going to be before you start working it. So it's when you see the planting shoot, because people are telling me, say, the banana, the planting and the banana, the leaf, them come out with spots on it, and the trunk, one of the trunk black and the other trunk not black. Hello. Me see banana grow with the trunk black, and me see planting grow with the trunk black. And me see the leaf them come variegated for the planting and the banana. So guess what? There is no countryman or country girl that me asks, how when I see a banana, how when I see a plant growing, I can differentiate it from a planting versus a banana. And if I ask 10 somebody, it's 10 different answers I'm going to get. You know how I know? Me know say the first one when me plant, I want planting. And the next one, I want banana. I don't know if anybody else in the class knows the difference, or if you can go speak to your parents or grandparents and ask them the difference and come back and tell me. I am not the dispenser of all knowledge, and I will sit and I will listen to you in order to know the difference. But I tell you, me don't know the difference. The difference is when it's true. So
maybe
Ryan is right up. Go ahead, Sash.
Maybe they would say there is a brown stripe on the plant.
That's what people always say to me. But I have seen bananas with the brown stripe, with a little brown patch on the leaves. So me come out and I say, oh yes, plant now shoot, bam, it's banana. So I go back to the country youth and say, country youth, you know, come from country, you're bogus. Him say, no man. I said, no man, it's a banana. So you look at it, come look at it, it's a banana. Right? And then now them start switching. I said, no man, this and others. I said, listen to me. You see, when me can look on one Julie mango leaf and no say a Julie, and me can look on one East Indian and no say one East Indian. Me can differentiate it. But guess what? I just cannot differentiate the bananas versus the plantain. So the point I'm making here is when you start doing, and it's not all the functions you see a clear pattern. There will always be patterns, yes, because mathematics is a study of patterns. But in this particular case, the pattern is almost clear. All right. So just as how we can guesstimate what f to the 5th power is going to be, when you write down the f to the 5th power, we can estimate what x to the 6th power. So guess what? At this point in time, I don't have to go do this boring differentiation because I have now seen the pattern and I can write this pattern down every single time. I can write this pattern down every single time. Now, let me just pause and just digress a little bit. When you would have completed your Calculus 2 and subsequent to your bachelor's, and you get into the place of work, you should be able to identify patterns in what it is that you're doing to make your job become easier. You must learn at this point in time to work smart and not hard. And a man may come and say, oh, you see, you develop a pattern. So you know what will happen. You know what will happen. Christmas come, you get paid from the 15th. You know, say 2 months later before you get paid again, because between the 15th of December to the 25th of January, it feels like 2 months, sometimes all 3. So you have to make sure, say, you have to pinch it. You have to pinch it. So you have to see the pattern, and guess what? Every year is the same thing. All right? So let's go. No, before I go, Are you all understanding what it is that we're doing now with the differentiation, being able to see the pattern and getting all of the information that we want up here? So everybody see that?
Yes, sir.
Yes.
Yes, sir, for this question.
For this one, no problem. For this one is fine. Because what I'm going to ask you to do is to go back to the ones that we've done before and see if you can identify any such patterns. Huh? Let's go. Remember now, recall this. All right? I just going to substitute the something that we don't know, right? F of 0 is 1. See, so this is this. F dash of 0 is -2. So this becomes -2x. See here, so -2x. And if we want to see it better down here, so -2x. F of 3 is 6. F of 2 rather is 6. So it's going to be 6 over 2 factorial now. So Rashim, I saw that as your answer, but I don't want you to give me 6 over 2. Don't give me 6 over 2. Break it down and call it 3. Remember 2 factorial is 2. 2 factorial is 2. So 6 divided by 2 is going to be 3, and 3 times x squared is 3x squared. See it right here, so? F triple dash of 0 is -24. See it here, so? This is going to be -24 over 3 factorial. 3 factorial, I remember now, it's not just 3. It is 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. So it is -24 divided by 6, which is going to be -4. So it's -4x cubed. And then finally, for this part of the question, is f to the 4th of 0 is 120 divided by 4 factorial. And when you do that, you're going to end up with 5. And it's 5 times x to the 4th. And this is my stuff. 1 minus 2x squared plus that. And that is what my Maclaurin's expansion is. I'll take your questions. Are there any questions?
Sir, so you wouldn't need to factor out the x in the question that x can be factored out in. You would just leave it like that.
Mm-hmm.
Oh.
When it's a factor out, what do you mean?
Yes, then, sir.
Meaning you could have 1 minus x in brackets 2.
Yeah, no, don't do it like that. Yeah, no, yeah. I feel that's what you're talking about, but I don't want you to do it like that. Yeah, don't do it like that. All right. Something
Sir?
just feeling to move. Yes, please. Go ahead, Sash.
After the 5x to the 4th, why did you put the sign to a negative? Or is it because there is a pattern in it?
So the next term is going to be negative. Plus,
Okay.
minus, plus, minus, plus, minus. Remember, you just told me that it's going to be -720, you know. Whatsoever 6 times 120 gives me, it's going to be -720 over x plus 1 to the
right.
7th power. Remember?
Yeah, but for the formula has a plus, right? So I was wondering, being that we stopped at the 4th differentiation, they would leave it there.
You notice what I did with this formula here? By putting my parentheses, my negative signs in my parentheses. So this, all of these are plus signs. Plus, 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 plus. If there are negative signs in it, the negative signs will come out.
Okay.
Sometimes you do Maclaurin's, and when you do Maclaurin's, every one of the terms is positive. And sometimes you do macarons, and the terms alternate. You follow what I'm saying?
Yes, sir.
And it depends, because the first term could be negative, the second term is positive, the third term is negative. So like in this case where the first term is positive, some functions that I give you, when you evaluate it, the first term is going to become negative. Meaning, when I substitute this in here, what if I'd given you negative 1 over x plus 1 to the second power? It means that this first term is going to be negative. Because when I substitute 0 here, so we have 0 plus 1 is 1, 1 squared is 1, negative 1 divided by 1 is negative 1. So this first term will be negative. And because I'm talking about a rational function, and the negative sign inside of the quotient rule will make this second term positive. So this will be negative, then this is positive, then the third term is negative. So that's what I'm saying to you. You can't just look at the function and say, oh, it's going to be plus then plus then minus. No. Some functions, when given, the f of 0 is going to be negative. F of 0 is going to be negative. Fair enough?
All right, sir. I'll make sure I'll say no, because I don't want you to say I'm careless when I do the workout.
Oh, and you know that Thursday, don't?
Exactly.
All right. All right. So I'm going to be following the leading of the Spirit.
Sure.
Mm-hmm.
I'm troubled by this question I was trying to work out today.
Which question is that?
Plus 1.
Sash, talk to me now. Give me a weapon.
Oh, I thought it was something. All right. Yeah, 2x over x plus 1 using the Maclaurin series. Sir, it's on your paper.
I have it on my paper.
Sir, it's example 2 she's talking about, sir, the one that you had told us to leave.
Example 2. But did I not do it?
No, sir. You say you were skipping it.
This one?
Yes, sir.
So Sash, what wrong with that one there? Quotient, the denominator times the differentiation of the numerator minus the numerator times the huh?
Yes, but some little things in there I'm troubled by.
All right. Let me attempt to do it, but not before I give you. Not before I give you this one. I don't see Tiana tonight. Where's Tiana? Let me give you this one. So we did this one just now. Yannick.
Yes, sir.
read that question for me, please.
Which part of it? All of it?
Mm-hmm.
Let fx equal 1.
No, man. The question, this one.
Oh. Obtain the first 4 terms
All
of
right,
the.
good. All right, stop. So notice in this case, it says including the term in x to the 4th.
Yeah.
But this is not asking for the first 4 terms of the expansion. How many differentials are you going to do in order to get the first 4 terms?
4.
Would it be 4?
No, 3. 3.
Aha. Very good. It will be 3 differentials. It will be 3 differentials. All right. I'm going to ask you to go ahead with this question. I'm giving you only 5 marks for this. Go ahead and do this question. You see? Hence, find the approximate value for e raised to the 0.03. How are keeping a John shop? Go and do this. The Maclaurin series of the function e to the 3x. On your mark, get set, go. I'm stepping away for 2 seconds.
Sir, we're supposed to do this one?
Yeah.
Oh my God. Hey.
Let me know when you're finished.
Complete foolishness we're doing now.
Sash, I'm confident you know how to differentiate your exponential functions. When not ask nobody. You know that. All right.
So I'm gonna finish up to what me can do it.
I hope that is up to the end of the question.
Good stuff, sir. Good stuff.
Where are the others? Sean, Ryan, Rashim, Lexton, Krishna, Jermaine, Alton.
Thing in us, sir.
So talk to me, no man. You can't just do the thing without you say something, you know. Talk to me, man. Let me know what I want. Krishna Hoisty.
It's still working on it, sir.
I must say I'm completely lost to this question, but I did something up to the fourth.
No problem. Don't worry about you being lost at this stage. Let me get a feel from the rest. Are we how close are we?
Sir, me the F dash dash. F double dash.
Hurry up.
Kind of right. There's some kind of figure it out.
Mm. Um. Mm. I don't want to get into the habit. You hear me? I don't want to get into the habit of posting the questions and then turn around to do the questions. I really want others to give a try. It's like what I hear Yannick say, boy, sir, me done right there saying on. I hear Lexton and I hear Sash. I want to hear from the rest of you to know that you're doing. I don't want any passive students in my class. You sit down, oh, him soon project it. I want you to give it an attempt. And if it comes to the point where I figure that students are not doing that, I'm going to tell you what it is that I will do. And I have done it before. I will say to you, if you're finished, WhatsApp me your work and I will WhatsApp you the solution. If you want to WhatsApp it to your friends, that's fine. But I will not post the solutions in my class. So when you're watching the videos, you will not see it. Sir, I saw you this day. I'm forcing you to be a part of the class and not to be passive. I want you to be active. This is one way of getting you to participate. So I don't want to just sit down. I don't want to get into the habit of posting a question. You're not doing anything. I'm answering the question and you're remaining silent. And then I'll come and I give you the answer. And then you say, oh, say the answer there. No. And I'm serious about it. If it happens, I will just send it to those persons who I know respond to me in class. And I say, look at the solution in the meantime. So let me ask the question again.
Sir, we can just jump out and say, when it, so for the first question, sorry, this question is basically something a bit new. So I would have to go and hold it until I see how you do it before I can attempt the rest.
Stop, Rashim, stop. Why do you say that this question is a bit new?
I'm not, the function E, power 3x, not sure or to do that.
Okay. You don't remember how to differentiate an exponential function? That's what you're saying to me, Rash?
Basically.
Okay, all right. I will excuse you because you did calculus 1 some time ago, right?
Yeah, but two years ago.
Okay, good. So I'll excuse you. What the others? Nico, in Jesus' name. All right, Nico, you tried. Tell me what you got for the first differential, Nico. Don't tell me that. Let me give you the easy one, Nico. What you got for f of 0?
Sir, I really don't know this question, sir. I just tried. So for the first, sir, I got 1.
Okay, thank you. I don't care if you don't know it. Just do this something. Don't keep doubting on yourself and don't stop doubting yourself, no man. Jeez. Stop doubting yourselves. Very good, Nico. So f of 0 is going to be 1. I need a taker for f dash of, what is it? What's the differential f dash of x? Somebody differentiate the function and tell me what is f dash of x, please.
Sir, I also tried that. I got 3e to the 3x. Don't know if it right or wrong.
Nico. Nico?
Present, sir.
Right. Is it the last part of it? I don't know if it's right. I don't want to hear that. So tell me the answer again and just rub out the last part.
All right, so I got the last part. So yeah. I got 3e raised to the 3x.
All right, good, full stop. You know, I not learn it, me hear the pop bottom of crepe out. Crave me?
No,
here,
sir, I'm not eating, sir. Sir, I'm not eating, sir. People is cooking,
okay,
but I'm not
all
eating.
Right. All right, cool. Very good, Nika. Excellent. So Nika gave me 2 answers. I need somebody else now to tell me. Very good, Nika. Somebody else to tell me what is f dash of 0 equal to.
3, sir.
Good job. Thanks, Charles. I need somebody else to tell me what is f double dash of x. Differentiate it and tell me what is f double dash of x. Somebody else.
9e 3 to the x.
Yes.
Sure.
9e
9e
3x.
to the
Sorry,
x.
9e to the 3x.
Very good. I need somebody else outside of those two, Yanika and Stash, will come in and come help out to tell me what is f double dash of x, f double dash of 0.
Nine, sir. 9.
Good job. Nice. And I need somebody else now to tell me what is f triple dash of x, the differential f triple dash of x.
27.
Yams, bananas, pumpkins, dumplings. I never said f triple dash of 0, and I said f triple dash of x.
Also E3x.
Good. And then you can come in and tell me what is f triple dash of 0 now.
27.
Good job. All right. So now that I know you're gonna do the work, I can post my answers. All right. So this is it now. So f of x is equal to that. And it's always problematic when you do the work in a rush. You end up leaving out some bits of information. All right. So you're correct. Rashim, when you do the differential of e to the x is e to the x. If you're given e to the 3x, it's going to be the differential of e to the 3x is e to the 3x, but you have to differentiate the function. And when you differentiate 3x, you're going to get 3, and you multiply by that. So it's going to be 3 times e to the 3x, which is this one here. And when you differentiate this is like a product, but all you can do is to say this 3, the differential of the numerator of the power rather is 3. So it's going to be 3 times this 3 to give you 9 e to the 3x. And this 3 times this 9 will give 27 e to the 3x. So you need to revise your exponential function. Remember, Whitney, Maclaren's can come with exponential, logarithmic, a rational function, a polynomial, a product, whatever else. So recall, there's something here. F of 0 is 1. So I'm going to have 1. F dash of 0 is 3. So I'm going to have 3x. F double dash is going to be 9. So we have 9 over 2, because 2 factorial is going to be 2. 9 over 2 x squared. 27 is going to be 3 factorial, which is 6. So we have 27 over 6. But 27 over 6 is the same thing as 9 over 2. Because 3 into 6 goes 2 times, and 3 into 27 goes 9 times. So I get 9 over 2 x cubed.
The next one would have been 81, right, sir?
Yeah, something like very good. You see the pattern now, don't?
Sir.
Can anybody see the pattern in that one? Why you talk to me now? Jesus.
Sorry, multiplying by 3 each time.
Very good. So you will see the pattern, as I told you before. Don't worry about it. The pattern will come out. Sir, all of them have a pattern? Mm-hmm. So you can tell the pattern before you start doing something. But the pattern will come out. All right? And then that will be my simplified form. Now it says in 2 minutes, it says, hence find the approximate value of e to the 0.03. Now, e to the 0.03 is me substituting 0.03 into my function. So anywhere in the function I see x, I substitute 0.03. See here, so 1 plus 3 times 0.03 plus 9 over 2 times 0.03 squares plus 9 over 2 times 0.03 to the cube. And I get this, 1.0941715. It never tell me how many decimal places, so me give them as many as possible. You double check that. Substitute that for me, please, so make sure that you know how to use the calculator to get it. And then I'll double check with you, and we'll call it a day. Or if you don't have much time.
Yes, sir, that's what I got.
Good job. Excellent. So what I'm going to have is, I'm going to have 1 plus 3 times 0.03 plus 9 over 2 times 0.03 squares plus 9 over 2 again. Today is the times 0.03, and this one is going to be cubed, equal 1.0941715. And that's how we get our, that's how we do our calculation. Now, one of the things that I keep saying to you is that I want you to get a natural display calculator. So I could do everything in one shot without having to go write down nothing. I just type out everything just as I have it on screen right here. I just type it out straight up into the calculator like that. And I get my answer in one shot. All right. This is where we're going to end for this evening. You performed better than you did last Tuesday. Please, guys, your mid-semester can drop anytime now, because we have covered the stuff. I didn't get a chance to look at some of the other things that I had planned for you, but now that's right. Don't worry about it. We should be fine. All right. Thanks much. Have a good one.
All right, so good night.
Nice.
Sorry, there's
Alright,
only
sir.
one recording I posted.
Say it again.
I realize there's only one recording I posted.
Yeah, man, don't worry about it. I'm trying to post the others, but on Sunday you'll see that one. But I dedicated some time on Sunday to post the others, and my internet just kept not going. And I really have some struggles with the internet, that is. But I was using the other time since Monday, since yesterday, to give some prerequisite override, and also I had my own challenges getting onto the system. So you'll get them, man. You give me a few. I make sure to send out the notes so you can go and look at something, and I have a conscience in the class. But yeah, man, you'll get it. Forgive me.
Okay, sir, no problem. Also, a question from the back of the classroom. Where does your edicus off this semester?
No, man. That too is I just need to promote you guys to matter of fact, let me do the promotion now. So you'll have access to Edicosoft now, because I'm going to promote you guys now. So forgive me about that one too. The Edicosoft is there. It's just that I don't promote you yet to Calculus 2. So no, man, you're going to get it. So you can start doing some work. And remember, I'm going to go through the last time. We want you to complete the work and complete the work promptly. Have a good one.
Love you too, sir.
Love you more.